Here's the interesting part. This is flowering time again. If you look at how big are these effects, so for example out here on chromosome 10 we have very, very, very strong evidence for a gene affecting flowering time. The largest effect of a QTL, in other words, the biggest difference you get from substituting the B73 version of the gene, whatever it is, with the another parent's version is about a day and a half of flowering time. That is the absolute biggest effect on flowering time we've mapped. Everything else is basically half a day to a day or less. What this means is that there are no really big effect genes for flowering time in this material. So how do you explain that you have lines that flower 40 days later than B73? What happens is, that's what this chart is, these late flowering lines here have late alleles at many, many loci, and they just get stacked together. So you have lots of genes that combined can give you very big phenotypic differences, but the individual gene effects are pretty small. So for flowering time, there's at least 40 genes with very strong statistical evidence, but the allele effects are small. They're also dispersed across diverse germplasm. Now we can resolve QTL actually at the gene level in this case, if you have enough markers. We don't have enough markers yet. If you put 10,000 more markers on the map, then you can resolve any position. Right now, if you've got a position you're interested in, you can make more markers and go in and rescore in those. So there's a plan to put 10,000 additional SNPs on the way, and then the thing will be done. Anyone can take this thing and measure their traits of interest and map these things down. So the data are all available at the project website. The lines are at the Maize Genetics Stock Center. People have already gotten these lines. There's a number of other groups growing them. The genotype data is all there. It's all out for the public to use. And it is the best genetic resource for complex trait dissection of any species. There is no other species that's even close. The mouse people have their complex cross. We still have higher resolution and we have more diversity captured than the mouse people. This is way better than anything Arabidopsis has, so we've left them all behind. For the time being, I'm sure they're going to catch up. Okay, so that's great. So linkage mapping from Tom Devine has gotten me to nested association mapping. And I'm ready to retire now myself. I'm so exhausted from that. But the second lesson I wanted to just point out that I learned was the tremendous power of phenotypic selection to shape cultivars for special uses, with no help at all from markers. But being a creative scientist, knowing what crosses to make and really doing selections for what you want to do, Tom has developed, as we've already alluded to, for example, these giant soybeans. I mean, these things just, there was no such thing before he developed them. Okay, and here he is. He's also done very nice work with the hairy vetches. So I have actually taken this to heart, and the other point is that this is all done on very, very minimal project support, really. Nothing. I mean, this is really bootstrapped kind of work, and yet there's good cultivars coming out of this, and that's a really good lesson for young scientists. That other stuff I was talking about, that costs millions and millions of dollars, and it's very exciting, and hopefully we'll get a paper in Science and stuff like that. But this sort of stuff is done really cheap. But it's very important to do. And so I've taken that to heart, and I have a little side project among the many other things I do, and that is to think about how is corn used in Latin America that it's not used in the US. So if you go, again, this is from Mexico, if you think about how maize is used in Mexico, there's all different kinds of food uses. Tortillas, there's something called atole, which is a drink. It's incredible, it's the best thing ever. There's tlacoyos, which you probably never heard of, but if you go to central Mexico, they're great. They're delicious. Pozole soup, you see that sometimes here. There are these big fat kernels in there. It's really good. Tortillas, tamales, all these kinds of things. We don't really have any of that here. So one reason is, if you take Corn Belt Dents and you try to get somebody to eat them, no way. Okay, they're fine for pig feed, but people really should get some better kinds of corns for these uses. The other thing that's really encouraged me to do this is in the Raleigh area where I am, the Mexican population has just exploded tremendously. So I think we have a market for sort of specialty ethnic foods, but hopefully it'll go beyond there, because I think if anyone else gets a taste of this stuff, they're going to love it. These are elotes. This is what I'm really shooting for first. It's basically corn on the cob roasted. So I mean, we have sort of stuff like that, but it's not sweet corn. It doesn't have sugary kernels. It's softer than dent corns, but it's not a sugary type. It's not so sweet. It tastes very good roasted though. What you need are big fat kernels, you need thin pericarps, and it has to taste good. So we're not there yet. But anyway, we're on the way. I made a whole series of populations from crosses between Highland and Central Plateau Mexican races like Cacao Simple and Mais Ancho to some U.S. materials that are sort of the closest thing we have to them. And this is just out of the nursery last year. This is an example of one of the ear sizes. There's a Sharpie, which is a standard scientific unit of length. So I mean, we're pushing 1.5 foot of an ear there, and that actually filled. And so if we can combine that with the large kernel size, you know, that's going to be great. And I'll finish up here with just another lesson I learned from Tom Devine, and that's also been alluded to. But it's great to be Irish. And, you don't have to be Irish, and that's the other thing. You know, Tom is he's really interested in people. If you spend any time with him, he wants to know where you're from, what your ancestry is. So it's okay if you're not Irish. You know, what if you are Irish? You know, that's extra special. And you know, just by dumb luck, and you know, I had the right ancestry when I came here, so we had a lot to talk about too. We'd be out there, you know, pushing the soybeans in, and now, James, do you know about the Battle of the Boyne and these sorts of things? So I got a lot of Irish history lessons. That's also got me a long way. So again, I just want to sort of follow along and say that, you know, I came here as an undergraduate, you know, a nobody. And Tom Devine spent a lot of time really mentoring me, and since then, I mean, always he's encouraged me and kept in touch, and he's taught me the other lesson is, you know, being a good person and treating people right. And I'm very thankful that I, just by dumb luck, ended up in his lab. Thanks, Tom.
Is with the Department of Geography and Environmental Systems at the University of Maryland, Baltimore County. And he'll be talking about nitrogen fixation, local changes, global impacts, or how nodulation genetics got me into a world of trouble.
This is all Dr. Kuykendall's fault, because he said you have earned the right to be funny. So I decided to give a talk that is going to be a little different than a talk that I normally give. Something just a little unusual, perhaps, but hopefully fitting for the occasion. Is that coming up yet? No. I just whizzed up here after teaching a class, so kind of just on my second lap around the block here for today. So yes, we're all here to honor Tom Devine. And I've got a few things to say. One thing you'll notice, besides the fact that I'm not Irish, is I'm also not a plant breeder. And I think that says a lot about Dr. Devine, in that he was really a person that could nurture pretty much any talent, anything he found that he saw that he thought could be encouraged. He would encourage it. And that was something I think that I've taken with me my whole career, is that encouragement to just go and do the things that interested you. So let's go through this here. Like I said, I had a little disclaimer here. I actually don't have a PhD or any training at all as a plant breeder. And looking back on some of the early days here at Beltsville, I first came here in the summer, I think it was 1981. I was a high school student on my way to college at Cornell University. And we hooked up by there was some kind of plan through American University to place students who, I was in the Westinghouse Science Talent Search, and they hooked me up with USDA, and Dr. Devine took me in. And probably from the get-go, I was already pretty convinced that I wanted to be a plant biologist, a plant physiologist. And I learned very quickly that that was not something that Tom Devine approved of. I was warned. That's all I can say. I was warned. The amazing thing is that partly it drove me half crazy. It's true. There I am in my apparatus after years in the basement of the plant science building at Cornell, driven half mad by carbon isotopes and all sorts of crazy stuff we used to do down there. And so, actually in the end, as you'll see, I didn't end up doing plant physiology anyway. So he was right all along. I should have taken your advice and saved years of torture and the horrors of scintillation counting and this sort of thing. But here is another face of Tom Devine, the stern taskmaster. I know Jim, I'm sure, experienced this. I'm not sure how many other people in this room. Yeah, Don Duggan certainly did too. In fact, we experienced some of this together. The brutal work of crossing soybeans in the summers here at Beltsville is really something. And I've got to say, Dr. Devine made his visits out there. But was he down there in the trenches with us? Not every day. You were out there every day. You were there every day. But not all day. Not all those afternoons. But anyway, you got to take a little roasting under the time. So anyway, so that was one of the things that I did, of course. But the other thing, and this again reflects really well on Dr. Devine. I was there for 3 years. I was here for 3 years doing research in the summers. After I had already started my ill-fated career in plant physiology. And I came back one summer, and Dr. Devine had set it up so I would learn two-dimensional polyacrylamide gel electrophoresis. The fact that I can still pronounce that after all these years is remarkable. It shows you how much trouble it was to learn that. From a man named Tommy, I can't remember his last name, Tommy Johnson, who was also a really hard-working guy. He really put up with some crazy interns like me. And we did some work on pretty much my own design. We worked on it together, Dr. Kirkendall as well, and came up with an independent project as part of the work. We also did all the regular work, but I learned a lot of stuff independently. And there's a whole lot of other stories I could say about independent work that I took on around the area, but we'll save that for the end. So anyway, so here I am at kind of the end of my ill-fated plant physiology career. Again, driven half mad by carbon isotopes and such. Before I even finished my PhD, and actually I went straight through at Cornell, undergrad and PhD, which is also something I don't highly recommend. Drives you half crazy. Before I even finished, I'd already changed my mind. I didn't want to study plant physiology anymore. I wanted to take a step back and look at something more broad. And this question of sustainable agriculture, this is would have been, I first got really interested in this in the late 80s, say 87, 88. What is the basis for sustainable agriculture? How can we even do this thing? In the late 80s, it was a popular subject to talk about this, and the USDA was already taking an interest in this. But nobody knew the slightest thing about what a sustainable agro-ecosystem would look like. Nobody had any idea. We were trying to reinvent this thing in the United States, where we had, what, 100 years of intensive agriculture. We had very little experience with this. I wanted to try and find a way to learn something about really a place and a system that had a long history of sustaining high productivity. What are those places really like? And I got my first chance. Another very brief mentor, unfortunately, this is Robert Rodale, who died very shortly after this trip. I took a trip on the Sustainable Agriculture delegation to China. This was in the spring of 1990. And he also encouraged me in this way, to look at this issue of sustainability from a place where people had actually sustained a system for a long period of time. So there I am. The funny thing is, I actually haven't had a ponytail since this time. And I had forgotten that I used to have a ponytail back then in 1990. Now I have it again. I don't know what the connection is there. And there were soybeans on the trip. So there we go, some narrow leaf varieties. This is in Harbin, right? The source of actually the original source of soybean germplasm, I think, right? Is that correct? Heilongjiang, China is believed to be one of the, so you see those narrow leaf varieties. That was one of the highlights of the trip, of course. Then I had this simple, kind of foolish idea. Okay, so now I have this idea. I want to study these systems in China. Now I'm going to get a postdoc in China and just do some research there. Well, people started to laugh at me when I started asking about this. And there was no support for some American to go do postdocs in China at that point. This is 1990. So I took a job as an English teacher at Nanjing Agriculture University to try and learn some Chinese and get a stronger feeling for what was it I would actually study. What was really the bread and butter thing. And that's the building I used to teach in. Those windows are broken. They're not just open. It was amazing. It was poor back then in 1990. This is one of the finest agriculture universities in the world. Nanjing Agriculture University. It's the Chinese equivalent of Cornell. Very, very good university. And there's some of my students celebrating there, 1990. I got involved in crazy things. Again, inspiration, not just from Dr. Devine. I have my own inspirations to do crazy things. But of course, it always helps to be encouraged. There's the first pizza place in Nanjing. Started in collaboration with some buddies in Nanjing at that time. Got a little bit bored without being an academic.